704 104 704104. Consider the sequence an is greater than equal to 1 and bn n is greater than equal to 1, defined by how an is defined. An is equal to e to the power n plus e to the power minus 1 minus n by 2, and bn is equal to an plus 1 by an. This is the thing how they are defining an and bn. Okay, which of the following statement is, they are asking which of the following statement is true. So bn is nothing but it is the ratio of an. So let's see what are the options. Option 1, for each x from R, each x taken from R, there exists an n. There exists one n such that n is greater than x. Such that what? N is greater than x. For each x from R, there exists an n. There exists an n such that n is less than x. N is less than x. For each x from R, there exists an n such that bn is greater than x. This is x. Okay, for each x from R, there exists an n. There exists an n such that bn is less than that x. So these are the four options. With the help of that, we have to solve and we have to say which one of them is correct. So let's solve. Solution. To analyze the sequences an and bn, to analyze the sequences an and bn, we first define the explicitly. What we have to, we will define explicitly. We will define an is equal to e to the power n plus e to the power minus n by 2. This is the an, and how we can write it as cos hn. Okay, in power it is n, so we will write cos hn, and bn is what? An plus 1 by an, so it is just like 2 will be cancelled. So what will come? Cos h n plus 1 by cos h n. Same thing when you will put this in place of an and n plus 1 n plus 1 in place here, then you will, after calculation, you will get this. So now we will go through to check behavior of an. Behavior of an. The function cos hn grows exponentially. How it is grows? Exponentially as n tends to infinity. As it goes to infinity, when n goes to infinity, it grows exponentially because the dominant term is e to the power by 2. This is the dominant term, because another term is there, e to the power minus n by 2. And when n tends to infinity, so e to the power 1 by e to the power infinity, so it will goes to 0. That's why we will not take that term. So dominant term here it is e to the power n by 2. As n tends to infinity, so n will goes to infinity because its dominant term is going to infinity, so it will go to infinity. So we are able to know that n tends to infinity when n tends to infinity. Okay, now we will try to know the behavior of a1 ai. So when we will take n equal to 1, then a1 is equal to e plus e to the power minus 1 by 2. Whenever n is 1, then a1 is equal to e plus e to the power minus 1 by 2 is that same equivalent to 1.543, and that is positive. Okay, so for n equal to 1, a1 is equal to e plus e to the power minus 1 by 2, and that is equivalent to 1.543, that is greater than 0. And an increases monotonically with n. And how, what is the behavior of n? It is increasing monotonically with n. Why? Because at a1 is this, but when n tends to infinity, it is en by 2, and that is goes to infinity. So it is more growing monotonically. You can check a1, a2, a3, a4 like that. You will able reach in this conclusion that en increases monotonically with n. Okay, thus for any x from R, that's why if you talk about any x from R, there exists an n. For any x in R, there will exist an n such that n will be greater than x. because x is from real number set of x is from set of all real numbers, okay, such that n greater than x. Since n is tends to infinity, n goes to infinity, okay. So there exists an n such that n greater than x since n tends to infinity. However, n is always positive. As we know that n will be always positive because a1 is positive and it is going to n tends to infinity, it is going to plus infinity. So will remain always positive. Either you take a1, a2, a3, whatever value you take, it will remain always positive and it will always increase also. Okay, positive and increasing. So, there does not exist an n. So there does not exist an n. So what will happen? There will not exist any n such that n will be less than x. So that n will be less than x, and x is from real number. And for x is what? X is less than equal to a1, and that is 1.4, 1.543. So here they have taken minimum value of a, that is a1, 1.543, and x is less than equal to 1. A1 means x, they have taken more less than that a1. So if I talk about an, an means a1, a2, a3, all of them, those all will be less than x. It is never possible. If you take x less than all other values, then it is not possible that x will remain, an will remain less than x because an is positive always. So it will always be greater than 1.543. Next, this means statement 1 is true. This means statement 1 is true while statement 2 is false. What is the meaning of this? This is that statement 1 is true and 2 is false. If I talk about statement 1 and 2, let's see here. Statement 1 is saying that for each x belongs to R, there exists an n such that n is greater than x. n is greater than that. While option 2 is saying that for each x belongs to R, there exists an n such that n is less than x. So as we have seen that n will never be less than x. So that's the thing. Option 2 is correct. Option 1 is correct. And option 2 is not correct. Next, we will move to option 3 and 4. So to know the option 4, we have to check about the behavior of Bn because it depends on Bn. And here it is x is there. Here it is also x is there. So behavior of Bn. Behavior of Bn. We analyze Bn. Bn is what? We already seen cos h n plus 1 by cos hn. Using the definition of cos h, if I use the definition of cos h, so Bn is equal to e to the power e plus e to the power n plus 1 plus e to the power minus n plus 1 by e to the power n plus e to the power minus n. And this one, what we can say, e to the power n plus 1, we can divide or not divide it. We can write in that form e into e to the power n. Like as we know that in multiplication, power are, if two terms are there, they are in multiplication and they are same, then their power will be gone, will be added. So that's why it will come n plus 1. So we can write this the first one in this way and second one in this way. And then what we can take, if it is possible to take common, then we will take, otherwise we will opt for other things. Let for large n, since it is not separable to take common and dismiss that, so we will go for other way around. For large n, we know that e to the power minus n will become 0 because 1 by e to the power n it will become, and e to the n tends to infinity, so it will go to 0. So it is negligible. It is around 0. It will goes to 0. That's why it is negligible. So Bn will depend on what? Bn will depend always on e into e to the power n by e to the power n. And if you cancel this, then it will come e, and that is equivalent to 2.718. So Bn as n tends to infinity, Bn is tends to e, that is 2.718. Now we will uh, go to know what are the values of B1, B2, those things. For n equal to 1 and for n equal to 2. For n equal to 1, B1 is e to the power 2 plus e to the power minus 2 by e to the power e plus e inverse. That is equivalent to put the values of e and take it square, and the value will come like this. And after solving, we will get this, and it will get 2.438. And again for B2, you will write e to the power 3 plus e to the power minus 3 by e to the e square plus e to the power minus 2, and that is equivalent to their value, and it will come to 20.136 by 7.542, and that is equivalent to 2.676. If you see the value, it is like 2.6, 2.4, after that 2.6, and when it tends to infinity, its value is 2.7. So it is increasing 2.4, 2.6, dot 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 2.7, like that. So as n increases, Bn approaches E. As n increases, what happens? Bn approaches E from below. Below value is 2.438. So after that in B2 it is 2.67, and after that it is goes to 2.718, means E, that n tends to infinity. Thus, Bn is bounded above by, that's why it is bounded above by E, and increases monotonically to E. And it is increasing monotonically to E. Till E, it is more increasing. For any x, if you take any x from R, and x is less than, if x is less than E, take that E so that it will be less than E. Then Bn will be what? Bn more than, always more than x. Then Bn more than x for all sufficiently large n. For all the large value of n. For large value of n, it is Bn is greater than x, because we know that Bn value start with 2.4, it goes to 2.6, then 2.7, like that. So for large value, it is Bn is greater than x and less than e. Okay, in between it will come, since Bn is tends to infinity. If x is greater than equal to e, if x is less than e, then for large it will follow. It will follow that Bn is greater than x. If x is greater than equal to e, then what will happen? There is no n. Then what will happen? There will be no n such that Bn is greater than x. There will be no n such that for that Bn will be greater than x. No any n will exist for that Bn will be greater than x. How? Since Bn is less than e for all n. For all n, we know that Bn is greater than e. Bn is less than e. We know this, that Bn is less than e. And here we have taken if x is greater than equal to e. We know that if all the value of x who are more than e, then there is no n for that Bn will be greater than x. Bn is always less than x. So this is violating. No any n will exist for that Bn will be greater than x. If it is becoming greater than x, then indirectly it is becoming greater than e, and that is not possible. So conversely, for any x in R, for x, if x is greater than e, if x is, we are talking about greater than e, then Bn is always less than x. Bn is always less than x for all n. Since so Bn will always be less than x for all n, since Bn is always less than e. Okay, so if x is always less than equal to b1 and it is 2.438, then there exists no n. If x is less than b1, then there will be no n such that bn will be less than x. Bn will not be less than x, because we know that bn is more than b1 and less than e. So b1 is 2.x and it is taken less than x. and Bn no not or never less than x, since Bn is increasing and B1 is 2.438 and it is the minimum. So it is not more than less than minimum. That's why this is also not true. So this means statement 3 is false and statement 4 is also false. Statement 3 is false. Why? Because x is greater than, whenever x is greater than equal to e, then there is no n. There will be no n satisfies Bn is greater than x. If Bn is greater than x, then indirectly it is satisfying that Bn is greater than e, and it is not possible. This is not possible that Bn is greater than e. If I talk about statement 4, this is also false because if x is less than equal to b1, that is the minimum value of bn, that is 2.438. So there is no n satisfies that b1 is less than x. As we know that if bn is less than x, if it is satisfied bn is less than x, say then it will come lesser than bn will be become, from here it will become like here bn is less than x and x is, here we have taken, here it is less than n equal to, it is b1. So that is not possible. It will be more than b1 and less than e. So if I talk about this, so this is incorrect. That's why it is not correct. So conclusion is what? Conclusion is that only statement 1 is true. The sequence n goes without bound. So for any real x, if you take any real x, there is an n. There will be an n such that an is always greater than that n, because at that place an is going to infinity. As we know, an is goes to infinity as n tends to infinity, but bn is goes to e as n tends to infinity. That's why an grows without bound and it goes go to infinity. So in this way, answer is 1, means option 1. For each x from R, for each x from R, there is an n. For each x from R, there is an n such that what will happen? Bn will be, an will be greater than x. What will be happen? An will be greater than x, and that is the option 1. So option 1 is correct. That's it.